and this is all involved in heating. This one asks about expansion in relation to heat. 4 metal rods of the same length and area of cross-section, so they're standardised rods, they're heated. Each rod is made of a different material. The bar chart below shows how much the 4 metals expand when heated through the same temperature rise. So we have very standardised conditions. We have the same length of rod, the same area of cross-section, the same temperature rise, and we're measuring the expansion. So iron expands, brass expands nearly twice as much, aluminium expands 2.5 times as much as the iron, and the invert only expands a tiny amount. So, part 1. Explain why invert is preferred to aluminium in making accurate meter rules. Well, meter rules can be used in lots of different circumstances, and the environmental temperature will vary for its use. However, you want your measurements to still be accurate no matter how cold the conditions are or how warm the conditions are. So, invert expands much less than the other materials when it is heated. So invert expands much less than aluminium. When heated. Therefore, it will be more accurate in warmer conditions. Now, the next part. A bimetallic strip is made of 2 metals. The one shown here is made of brass and iron, and it is used in a fire alarm. Using the information shown in the bar chart, label the diagram with the metal used in each part of the bimetallic strip. Write your answers in the boxes provided. Well, the materials that you're most familiar with when you learned about the bimetallic strips are brass and iron. Now, we want the material that expands most to be on the left-hand side. So when it expands, it pushes and bends the bimetallic strip over to the contact screw, which will make the circuit and ring the bell. So we look at our chart above and we see that brass expands more than iron. Therefore, the brass must be on the outside. So this one is brass and the top one is iron. Now, you could use any of the metals listed in your bar chart. Personally, I would tend to use the iron and brass because it's the way that you learned it in your notes. It's more familiar to you. But you could have used, for example, aluminium and iron, as long as you put aluminium in the bottom box. Or you could have used aluminium and brass, as long as aluminium's in the bottom box and brass is in the outside box. And similarly, you could have used invert. As long as you have the material that expands the most in the left-hand side of the strip, which is the bottom box, any will be suitable. Part 3 then. Explain how this fire alarm works. Now, when you're explaining how the fire alarm works, you should make reference to the materials that you chose in part 2, the iron and the brass. You must make reference to those materials. So first of all, we start with the brass expands more. And that will get you the first mark out of the 3. So the brass expands more than the iron. This causes the strip to bend. And it causes it to bend towards the contact screw. And because the strips are riveted together along their length, the brass forces the iron to bend over. This then, when the contact screws meet, this completes the circuit, as metals are electrical conductors, and then sounds the alarm. Right, so the first mark is for brass expands more than iron. The second then is causing the strip to bend towards the contact screw, that bending action. And the third mark then is for saying that it completes the circuit and sounds the alarm. If you get the two metals the wrong way around here, you would lose this mark, but you can still get the other two whenever you refer to the bending and making the circuit. Part 4. Explain how the fire alarm could be adjusted to make it operate for a smaller rise in temperature. And note that in this question, they're also assessing the quality of written communication. Therefore, you want to aim to have good spelling, proper punctuation and full sentences. However, for the ease of explanation here, I'll use point form. You could make the gap smaller between the contact screw and the strip. This means that less expansion is needed to make contact. So that's the first possible answer there. The second possible answer that you may have given is that you could replace brass with aluminium. Still keep the iron as the other metal, but if you replace the brass with the aluminium expands more and will make contact more quickly at a lower temperature. Right, so it needs a smaller temperature rise for the aluminium to expand more, which will then cause a greater bend in the bimetallic strip.